Hi friends, let's get into the second module of 21 CS 644 Data Science and Visualization. The module is titled Exploratory Data Analysis and the Data Science Process. In this module, we look at the various techniques used for exploring the data and analyzing the data, and then we look at the process of the data science. The exploratory data analysis, in short EDA, is a crucial initial step in data analysis. The primary goal of EDA is to summarize the main characteristics of the data set. Usually data set is very huge in number, big data. So to understand the characteristics of the data set, what we require is a summary of it, and EDA provides that summary. So this summary is given through graphical and statistical techniques, and this helps analysts and the data scientists to understand the structure, patterns in the data, and the potential issues with the data before formally modeling or testing the hypothesis. So what we have on our way, a road show. So we need to look at the data summary, data visualization, how the data is cleaned, the features from the data to be extracted, and then how to explore the data. And exploring the data will provide us a pattern to be recognized from the data, and then we need to know how the information about the data can be communicated, and finally the various tools available for EDA. Coming to the first point, that is the data summary. It's a overview of the big data. So it summarizes the big data into few parameters. So there are many types of data summary are possible. So one of them is descriptive statistics. So it used to compute the basic statistics like mean, median, standard deviation, minimum, maximum, and other quartiles to summarize the central tendency and variability of the numerical features. The common usage of this is to express the overall distribution of the data. So we can talk about distribution of the data in terms of mean, median, variance, minimum, maximum, quartiles, and all that. And this will help mainly in comparing whether the two data sets belong to the same process or not. For example, if we have two data sets and if we could compute this summary and these two data sets have different means, then we can undoubtedly declare that the two data are coming from the very different sources. They don't belong to the same process, and so on for other details in the descriptive statistics. Or we can represent this in a summary table. So this creates tables that provide overview of the data sets like counts. So how many data of each parameter are available, and in terms of percentages, and then summary statistics for categorical variable. So if the data is categorical, then we provide so how many of the data belong to each category. So in terms of percentage, we can give this description. Then coming to the visualization part, so there are various techniques available for data visualization. So the most common thing used is a histogram. So this will display the distribution of the numerical values to identify the patterns, skewness, and potential outliers. of the features. The next one is the box plot. It is used to visualize the spread and central tendency of the numerical variables, so making it easier to identify the outliers. Then we have scatter plot, that's used for comparing between two variables. So a relationship between pair of variables can be explored and used to detect any patterns and try to find is there any correlation between the pair of variables. So the two reasons for finding such correlation is one, if the pair talks about input output pair, then we try to identify whether output depends on the input. In that case, we can represent the output in terms of input as a mathematical expression if we can identify the relationship between the two, if they are correlated, and if we can approximate the relation between output and input in a mathematical form, then the big data can just get condensed into one mathematical expression. That's a positive part of that. The other side, if you are looking for scatter plot between the pairs where both of the variables are the input variables, and if you can find that there is correlation between them, that means both the parameters are talking about similar details. So we have redundant parameter, and a redundant parameter means unnecessary wastage of time and energy and space and all that. So if we could identify that two input parameters are correlated, then we can drop one of them and make the process simpler. So that scatter plot has got two major works to do. One, to identify correlation between input and output and then convert that into a mathematical expression, or correlation between a pair of inputs, and if found, then one of the inputs can be dropped. Then we can plot this in the heat maps. So here the correlation matrix, that is a relation between pair of variables, is identified, and for the correlation is represented using color. So the higher correlation or stronger correlation, one side of the color is used, and for no correlation other type of color is used. So there is a color map used for representing correlation. So when we are working with multi inputs, then the correlation between pairs of all the inputs we can just put at one image, and then we look at just observe the colors of the plot at various junctions between the pairs, and that will tell us how they are correlated in pairs, and then we can take decisions as to what are important, what are not important, and all that. So if you are the pairs contain, one of the pairs contain the output, then the stronger correlation, that means that input should be retained. A weaker correlation with the output, that input should be removed. And if it is between the two variables, the stronger correlation is found on the color map, then that should, one of them should be eliminated, so that the process becomes simpler and all that. So this one color image will tell us the overall relationship between all the pairs of parameters, input as well as output. Then we have a bar chart that represents the distribution of the categorical variables. Histogram is for numerical variable, whereas bar chart is for categorical variable. So how much of the each category data is available in the data, so that shows the either count or proportion of each category. So that's some visualization techniques that are available. More details we see in the coming sessions. So till then, keep watching. Thank you.